Hello everyone, I'll just whisper a bit at the beginning just so you can get your volume right. Hopefully you're listening to this with earphones. If not, turn the volume down enough so you can hear it, but not so you're disturbing other people around you who might still be working. This is another thing that we're going to skip over pretty quickly. You did it last year in Year 8. I'm just refreshing your memory. I'm going to run through some examples here. You're going to need to go home and do some practice on these in your homework program, because it is something that's expected you're able to do. And like I keep saying, it's just area. Follow the formula and follow the procedure. For those of you that don't remember, a composite shape is something made up of two or more shapes, for the want of a better word, I guess, just fused together. So let's have a look at an example to begin with. Now this looks like a big fat L. There is no formula for the area of fat L. I think it's pretty obvious to you right now that this is going to be broken up into two shapes we recognize. But before we do that, I want you to have a look at this. There's a couple of things missing from it, and this is an important part of it. If you have a look here, I've got that line marked as 20 centimeters, that one marked at 18. I've got this one as 13 meters. I think I said centimeters a minute ago. It's all in meters. Sorry. If I said centimeters, I apologize. It's all meters. What's missing is there is nothing there and nothing there. Now, before we can go on, we need measurements on all sides. Hopefully, you've noticed that you'll be able to notice this pretty obviously, I would think. That if it's 20 centimeters all the way down there, and it's 14 centimeters all the way to there, then surely it has to be another 6. I think I said in centimeters again. Try and get it right this time. It's meters. So it's got to be another 6 meters right there. Because 14 from there to there and 6 from there to there make 20. So if it's 6 from there to there, it's got to be 6 from there to there. Let's have a look. 6 meters marked there. You should have noticed the other one by now, I hope as well, that if it's 18 meters across there and it's 13 meters across there, well, 13 plus what gives you 18? 5. So that's 5. So up here should be 5 as well. Let's have a look. Now that we've got all the measurements right, I think you should hopefully have noticed by now, we don't have a formula for the area of this, so we're going to try and break it into something we recognize. That red line there has just broken this into a rectangle just here and another rectangle just there. I'm not going to label it on the drawing, but we're going to call them Area 1 and Area 2. This red line, normally you would do that as a dot. Just on PowerPoint or Keynote, I don't really know how to do a dotted line. Not sure you really can. So I've just done a red line. So we've got a rectangle here, a rectangle there. If you broke it up this way, you'd get two different rectangles. Your final answer would still be the same. So let's have a look at what we do here. Start off with, we're going to get the area of this rectangle right here. Area 1, we're going to call that, is length times width, which is 20, times 5, which is the length, which is 100. We've now got the area of that rectangle. Now let's get the area of this rectangle. Area 2 is length times width, because it's a rectangle, which is 13 by 6. Now, be very careful. A really common mistake here is to say 13 by 18. 6 by 18. It's 6 meters wide, and you look at it and go, oh, it's 18 long. But if you look, it stops there. It's 13 by 6, which is 78. Next way, get the answer. So, you've got area 1 and area 2. What do we do to get the area of the whole thing? We add them together. Area equals A1 plus A2, stands for area 1 plus area 2, which is 100 plus 78, which gives you 178, and very importantly, 178 meters squared. Not meters, meters squared. Let's add another example. Pardon me. I needed to cough and I don't want to have to start recording again. I'm hoping by now that you've spotted the two obvious shapes that make up this shape. But before we get any further, can I highlight this? Again, normally this would be showing you with a dotted line. A dotted line are lines that show you information you need, that aren't part of the shape. Again, I couldn't do the dots, so I've done them in red. What that's showing you is if we make a perfect right angle there, then this line up here is what we call the vertical or perpendicular height, which is very important to a triangle. So let's see what we found here. Hopefully you're all onto this. If I break it up with that purplish line, you should be able to see I've got a rectangle down here and I've got a triangle up there. So we're going to do the area of those two shapes separately and then add it together just like we did before. Let's go with the first bit. Area 1, length times width, which is 25 times 30, which is 750. This is what we've got the area of this rectangle here. Please don't do the mistake I'm going to suggest on the next one. Area 2. It's a triangle. Don't write length times width, for goodness sake. It's a triangle. You've got a different formula for a triangle. A half times base times height. Or, as we shorten it to, a half BH. A half times 25. If that's 25 across there, then the base of the triangle is also 25. So even though it wasn't marked, it was obvious that it's 25 centimeters as well, multiplied by the vertical height. Not the sides of the triangle, the vertical height shown by my red line there. So 1/2 by 25 by 10 gives us 125. Hopefully your brain is already ahead of mine. What happens next? You add the two of them together. 750 plus 125 equals 875, and again, centimeters this time, squared. Okay? Don't forget the squared. You'll lose marks if you don't. This is just area, guys. You do area of two different shapes. If I gave them to you separately, you'd all get it right. So if I put them together in one shape, you shouldn't get them wrong. It's no different. Just a little bit more effort, a little bit more work, and a little bit more time. That's all. Okay, guys, one more and then that'll do us. In this instance, I haven't got two shapes fused together or two shapes combined together, so you'll see at the end we're not going to add. Let's call this circular bit a swimming pool. It's a nice round blue swimming pool in the middle of our square backyard. The yellow bit, let's make it, say, paving that's going to go around the pool. So we've got a lovely round pool and some lovely brick pavers around there. In this instance, I don't want to know the area of all of this. All I want is the area of the yellow bit where the pavers are going to go. I don't want the area of the pool. You'll find out the area of the pool as a stepping stone, but I don't want it actually as the final answer. Pardon me, let's have a little look here. So step 1, find me the area of the entire backyard. Pretty straightforward. Area equals length times width, which is 10 times 10, which is 100. Pretty straightforward, wouldn't even need a calculator. Next step, give me the area of the circle, the swimming pool. Do not write area equals length times width or a half BH or something dumb like that, guys. You've got to do better than that. The area formula for circle is pi r squared. So use the right formula, which becomes pi multiplied by 3 squared. The radius is 3, which when you do it on a calculator and round it to 2 decimal places is 28.27. Now, as I said earlier, do not add this. It's not one shape sitting next to or on top of another shape. We've got the area of a big backyard. In the middle of it is a pool, and I do not want to include the area of the pool because I'm not going to pave the pool. That would be stupid. So, next step is actually a takeaway. Take away the area of the pool from the area of the big square backyard, and we get 71.73, and highlighting again, good old meters squared, not meters. The next step might be to tell you how much pavers cost and see how much it will cost to pave it, etc., etc., etc. Pardon me again, guys. Battling a cold. I'm not going to start this recording over again. That's it. That's composite areas. They are just areas with a little bit more thought involved. We're not going to spend a lot of time on it. You need to do some of this in your homework program. Please, please, please do so. See you in class. Bye.